compare a few different welfare policies and see how graphically they look. And talk a bit about income substitution effects with numbers. So I'll set up a little world here. So we have, we're going to look at welfare via TC. So we have, let's say we have Monica and her wages. We're always working with people whose wages are like $10 an hour. We're just going to be really nice to Monica here. Our wages are $100 an hour. Which, if you compute it, is not actually like a crazy amount of money. But anyway, it's a lot, but it's surprising how much wages are. Okay, so wages $100 an hour, and she has. And again, you can make this realistic, 40 hours a week. Let's say she works about 40 hours, so 40 weeks in a year, roughly. So she has something like, around 2,000 hours that she can either leisure or work. I'm adding more because obviously she sleeps, and so she sleeps, but every waking hour, presumably she can work, and then some of it I'm just going to chalk off. Let's say she sleeps a lot. She only has 2,000 hours that she can decide if she can work or leisure during that time. She has a kid, that's not really leisure, so we're going to count that as sleep, basically having to deal with a kid. She's going to have a kid. So okay, so this is the setup, right? And we want to know sort of what her situation would be like under a different series of welfare policies. So what we're going to start by looking at is like a basic welfare case. So the government decides on like a cash welfare program. And the way that it works is anybody who earns less than $30,000 gets a $10,000 check. Right, so institutes cash welfare. Anyone who earns under $30,000, it's a $10,000 check. And so question A might be, what is the effect of this policy on Monica's budget line? Not her decision, I didn't tell you what she was choosing to do, but we just have this, just anybody who earns this, I just want to see what her budget line looks like before and after. So let's quickly put up, what does it look like before? How would we draw our budget line before the policy? What do we put on the axis? What do we put on the x-axis here? Leisure. To the y-axis, consumption. What do the budget line intercepts? On the x-axis, for leisure, 2,000 hours. Leisure in hours. And how about on the y-axis, what's the intercept? 100,000. So that's the old pre-policy budget line. We want to be really good at drawing that one. And it's always helpful to put it in there because it's confusing to draw EITC on top of like nothing. Sort of, you're arbitrarily drawing lines and slopes, and ultimately the EITC lines are going to come back and hit the old budget line. So there's that roll in there. Okay, so what's the next step here? So now we've got this cash welfare program, and what's that going to do to our budget line? So I'll give you guys just 30 seconds to try to get it started on your own, and then we'll work on it together here on the paper with different colors. Okay, so what's our first step here? What I always tell people is start on the bottom right. I know we're used to starting on the top left and drawing like a voucher and all that from last semester. Here you want to now start with your graph here on the bottom right. So what's happening if you just leisure all day under this policy versus what was happening before? Now you get $10,000, right? So we're going to have a little line that goes up here to $10,000. This point is going to be on our new budget line. Because now if you, again, if you leisure 2,000 hours, you get $10,000 worth of consumption. What happens if you work an hour? Just 1 hour. How much consumption do you get? Or does Monica get? Given her wage. So if you work 1 hour, 10,100. And it's not phased out or anything like that because she gets it for, no matter how many hours she works, as long as she earns less than $30,000. So how many hours of work will it take Monica to reach the point where this policy no longer applies to her? How many hours of work? 300? Once Monica works 300 hours, she's earned $30,000 from her job. So at that point, she's hit the limit. Like anything beyond 300 hours of work will render her ineligible for this benefit. Right? So you can kind of know that once she leisures at 1,700 hours, that's the point at which she's earned $30,000 from her work. Right? And that'll take her up to a total income or a total amount of money of what? How much will this be on the y-axis? 40,000. All right, why not 30,000? Because she earned 30 and then got the 10,000 benefit right at that point. Sorry, this should be parallel. There's the back door. This should be parallel to the red line.
But the person who earns 30 will get the check.
Yeah. So I'm gonna. Yeah. I mean, in theory, this is an open circle, right? Like this point here is like a. If you guys remember from geometry, it's like open in the sense that if you're right at that point, it doesn't apply to you, and we have a closed circle directly below it. So this would be like a solid point. But right. This kind of thing. This is sort of not to scale at all. I'm going to try to draw a better version of it and give you guys a second to sort of try to compute what you think is going to happen next. Sorry about that. I want to make sure the graph makes sense. Yep.
Can you describe for a second this program would be not much like that? Like program that would be the right angle?
Right, so that would be something where once, like we're going to give you $10,000, and then we're going to reduce your benefits by $1 for every.
So that's a 1 for 1.
1 for 1 would be flat. Because if you start working, you get exactly the amount of money that you get under the benefit. It's like you earn $1 and you take away $1. That applies to many PhD students, actually. So if you have a fellowship, you get a salary related to that fellowship. And if you teach, they take away, you have a benefit reduction rate of $1. So Harvard will actually take $1 away. So people who have fellowships do not teach. Because there's no point. Because if you teach, they take away your fellowship money 1 for 1. So literally, this is something that applies to everyone. If you ask any doctoral student, they know that their benefit reduction rate is if they're on fellowship. They cannot earn any other income. That's why I never apply for fellowships. Okay, so let me try to draw a slightly better. I know that's very esoteric. But, okay, I'm going to try to do this a little bit more accurately. Sure. So, well, we still haven't finished drawing this budget line. So you want to make sure that you have it all the way through. Here's what we have. Right, so we've got this. But we're not done yet. Right? So this new budget line kind of goes up like this, and then it's flat across up till there. And then we said this was 40K. So that's 40,000. Well, you've worked 300. She's worked 300 hours and earned $30,000 plus 10,000. So importantly, this amount here, and this is what was not quite the scale before, and still not really good. Sorry, but that's 30,000. Right? That's what she actually earns, is given by the red line. Right? But the benefits are added on top of that. Once she earns beyond 30,000, she's back on her old budget line, right? So at that point, you've got that kind of notch thing there, and you've got something that looks like that. So the budget line kind of jumps down there. And that's that open circle, closed circle thing. That once she's right at that point, technically this is an open circle, and this is a closed circle. So if she's right exactly at 300 hours of work, she'll technically be down here, not up here. Because the policy was anyone under 30,000. But that's kind of semantics. You don't have to worry about that if you draw it. That's just a closed circle, and full credit. It's just applies that 1 point. Yep.
Yeah, on that point, we say she won't work for 30,000 if we get it wrong. Or should it be 30,000 and more? But that's all, sometimes it says 30,000.
You can just say that she would not choose to earn, if it says under, you can just say she wouldn't choose to earn 30,000 but you're not going to get it wrong either way. Like, I mean, that's, if you say that here's the range that she would work and it's correct and you have 30,001 or you have 30,000, you're going to get full credit. So the question here might be, and I'm not going to make you guys walk through it, but what levels of hours worked does it just seem like she's never going to do? Well, you can kind of see that, like, if she earns like roughly 30,000, that she'll be roughly at actually getting 40,000. Again, might give or take a penny, right? I mean, we're literally talking about a penny difference. So we can let's just assume that it's right at 30,000, just so we can talk about 30,000 and not 30,000 minus a penny. So if she earns right here, she'll get 40,000. Why would she choose to work another hour after that? Because that would just move her down here. She would be choosing to move down and to the left. She should never choose to move down and to the left from this point. It makes no sense. She can choose to move like this way or this way. Obviously this way she'd love to go. Here or here, it's a trade-off, it's fine. Moving down to the left is getting less of both goods. That makes no sense. So she would never choose any of these points on this part of the budget line because it's down to the left of another point that is on her budget line. Right? So what levels of earnings are captured by these points here? Like 30 to 40,000 earnings, which would be how many hours more here of work? So another 100 hours of work, so this should be 1,600. So she should never work between 300 and 400 hours. Doesn't make sense. She can get 40,000 for just working 300 hours. Why would she work 35 hours or 40 hours to try to get less than or equal to the 40,000 she could get by working less? So you want to be able to compute that kind of situation as well.
Sorry, I'm confused. How do we know where to draw the line?
How to draw the line? Where to draw the 30, this 30 thing? Well, if she works for 300 hours, her salary is going to be $30,000. Plus, she gets the welfare. Takes her to 40.
Oh, right.
Okay, so this is sort of an unrealistic. Oh, you have a question?
Just from the 40,000 mark, we have a straight line right now, the dot line. Like this down? If you were to-
This one here?
No, from 40,700.
To 200K. Oh, this one here?
That should that be?
That's dotted. It's dotted. So it can be solid or dotted. You're not going to be there. Right? You can't. Like, it's a jump. It's like right from this point, you jump down to here. You can't choose to locate it right here, right? Because if you are eligible, you get the check in the mail. So you can't be like, I'm only going to accept half of the check. That's basically, so if you make it solid, it implies that you can only cash half of your $10,000 welfare check, which sort of doesn't make sense. You either cash it or you don't. So you either choose that point or you go below. Vertical line over 2,000. Right, so here you can choose, again, it's whether or not you choose to cash it or not. Presumably you choose to cash it. So, I mean, you can see you can't really draw a difference curve that's tangent to this straight line. Right? I mean, it would be tangent to that point. So, okay, so, all right, so let's talk a little bit about what we have here. What if the government, so this is unrealistic as a policy. What does the government usually do? They usually phase out your benefits, right? So what if someone came along and said, look, I want to reform this policy. I want the benefits to phase out evenly such that no one earning over $70,000 in their job gets any welfare money. So let's keep the same $10,000 check, and I'd like people under 30,000 to get to keep all of it. but I want to phase this program out evenly. I don't want to have like a tiered phase out. I want to phase it out evenly in a way such that anyone who earns $70,000 does not get a welfare check. That anyone who earns less gets some welfare. And so I want to help people who earn $70,000 or less. It's a realistic policy, and certainly a senator who's from a state who have a lot of people earning in that range might be interested in that. I might pick that number specifically for his own purposes or her own purposes. So what would that do to this line, and how would we compute the benefit reduction rate associated with such a policy? So that might be the question, is what's the benefit reduction rate that's associated with a policy that enables benefit, the break-even point to be 70,000?
I have a question. Do you want the whole program to be a fade out, or do you want the first 10,000 to go up to 1,700 hours and then fade out?
I want $10,000 to go to anyone who earns under $30,000. I still want this part of the budget.
You want to phase out from 7,000?
I just want to phase it out from here.
Okay.
And the question is, how much do I have to phase it out per dollar? That's a good question. I don't want to phase it out from the beginning. I'm going to start phasing it out only for people who earn between 30 and 70,000. So the question is, what would happen to the budget line, and what would the benefit reduction rate be that's associated with that? So there's a little spin on what you've done before. I'm just going to give you guys like 15 to 30 seconds just to, well, how would you start approaching this? Just in the interest of time, we'll just jump right into solving it. Again, we're talking about Monica, whose wages are $100 an hour. So the question is, how many hours would it take Monica to reach the $70,000 earnings threshold that we want her to no longer be eligible at? 700 hours? So how many hours of leisure is that? 1,300. So we kind of know that this 1,300 hours of leisure is going to be like an important point. That's where we want Monica to no longer be eligible for benefits. In other words, we want that to be the point where our phase out hits the old budget line. So we're kind of adding a third. Let's see if I have. I guess that's will work. So we're adding a third budget line here, which is going to kind of be the same thing here. And now from this point on, we want it to actually phase out, such that right at 1,300 hours of leisure, the program is fully phased out. I don't know what the slope is yet or anything like that, but that's the question, right? And how do I know it phases out right there? Well, at this point, on the old budget line, she's earning that 70,000. And under this policy here, I'm going to kind of dot it so you can see it more clearly. Under that kind of jagged line, this policy is phasing out over the course of her earning between $30,000 and $70,000.
Wouldn't the phase out line continue until you hit the 10,000 mark, like right above? Or like, why is it going on the other policy?
Why is it going above this?
Why is the slope changed, like in the middle?
Why is the slope, in this part right here, why is the slope changing there?
Because you get benefit reduction, and so it's like for every dollar that she earns in wages, she's actually losing money from the benefit that's being taken away.
Why does it go back to the parallel slope at that point instead of 200?
At this point, why does it go back to this?
Yeah.
Why is this slope different than this slope? Well, because here, I'm not reducing your benefits. If she earns 20,000 and she gets up to 25,000, we're not phasing her out. Because I want to keep the element of the policy, which is anyone earning less than 30,000 gets to keep the full welfare check. There's no phase out for those people. I do want phase out for people who earn between 30 and 70,000. So only in the range where she would be earning between 30 and 70,000 on her own through her labor, do I want this policy to phase out. Right? And so that actually is a good point about the slope as well. Why is the slope flatter here? Remember what the slope is. It's negative the wage. And it's her effective wage. And that's less here because her effective wage is affected by the fact that she gets her wage, but I'm taking some of it away. So let me put this in a different way. She's getting her wage, and she's getting to keep her full wage, but I'm removing benefits at the same time. in such a way that she feels like her wage is smaller. It's not like a tax on her wages, but it acts like a tax on her wages. Like if I tell you, like I'm giving you $10,000, but every time you earn $1, I'm going to take 30 cents away from that 10,000 I'm giving you, it kind of feels like a 30% tax on the money you're earning, even though the boss who's paying you is still paying you that full amount, right? What I really care about is how much money do I have now when I work another hour. And so what is this benefit reduction rate? How do I figure out how much it is? Well, what is the slope of this line? Well, 30, we can calculate using these 2 points. $30,000 height, right, and the base here is at 400. So negative 75, right, which is 30,000 divided by 400, right, gives you the negative 75. So the slope of this part is negative 75. So what does that mean? Remember what the slope of the budget line is? It's your effective wage. So that means that during the phase out, Monica's effectively earning $75 an hour. What does that mean the phase out is? What percent of her income is being phased out? 25%. Her wage is $100 an hour, but she's somehow seemingly only walking away with $75 an hour. Well, she's getting $100 from her employer, right? And $25 in benefits is taken away at the same time. In other words, a fourth of what she makes is taken away. So the benefit reduction rate here is 25%. Every dollar she earns, I take away a quarter from her. Every $100 she earns, I take away $25 from her, leaving her with 75. So the nice thing is here, if I just kind of know where this thing hits here, you can just compute the benefit reduction rate looking at the graph and not having to do any weird math. So knowing that where benefits cut out and the break-even point being here helps us just kind of skip a few steps.
So what was negative 75
Is 25%. Because the slope being negative 75 means her wage is effectively going from 100 to 75, which is a 25% reduction. Incorporation, yeah. Yep.
How would you apply these numbers to that, the B equals G minus TWH?
Right, so that formula that you're given on the exam, right, is benefits equals G minus TWH. And so it's sort of saying that this is like your, WH is like your earnings, right? And this is like your benefit reduction rate. So this is the B here, we're kind of trying to compute, our G is sort of the amount of the grant, that's at $10,000, right? And we're saying we're phasing, so we have $10,000 to check, except that we take away T dollars for every dollar you earn. So T is the benefit reduction rate of 0.25. And the question is, how much earnings does it take to have that disappear? So in this equation, this would be 10K. G is 10,000. The T is your benefit reduction rate. WH is your earnings. So this equation will tell us sort of how much earnings you would need for your benefits to go to 0. And so, I mean, you would use that to apply that to get the distance between here and here, right? Because our benefits, or you could also use it to say, look, I want benefits to be 0 here. So 0 equals 10,000 times benefit reduction rate times, what her earnings would have to be. Which I know is 70,000. Right? That additional 40,000 I need her to earn. But I mean, I frankly find this very confusing. So if you like it, I mean, come by and chat with me. I can talk to you a little bit more about how to apply this in this case. But you apply it differently in every case. That's the problem with this formula. I'm happy to stick around. I mean, it's technically over, but I'll stay around and kind of add the ITC on this, on top of this, or if it's a smaller group, we'll just sort of talk about whatever people want to talk about. So feel free to head out.